Hey everybody, this is Alex Merced from alexmercedcoder.com, and I figured I'd do another teach myself a language a video. So in the last video we did Scala. I taught myself Scala in about 20 minutes. And again, not didn't master the language per se, but was able to kind of understand how it works and play around a little bit. So we're going to do that again with a different language. So we start a new REPL. Let's take a look what we got here. Something I haven't done videos on. Let's do Scheme this time. Scheme is a functional language that actually was partly inspiration to JavaScript. So let's see here. Let's see if we see any of those similarities um, when we use this. Create REPL. Okay, let's try an example. Hello world. Print hello world. Oh, and those are we got parentheses. Okay, if you've ever done like Lisp or something like that, like Clojure function. This is a functional language, so that means there's going to be a lot of parentheses. So let's look up scheme syntax, and let's start learning how to use scheme. Okay, program consists of a sequence of definitions and expressions. Okay. Okay, this is probably not the best. Scheme language basics. Let's try that. I always find the documentation for functional languages always very lacking in giving you sort of informative examples. Scheme expressions. Okay. So let's see here. Scheme expression is a construct that returns a value, such as a variable reference, a literal procedure, or a condition. Expression types are categorized as primitive or derived. Essential syntax: an expression consisting of a variable. Section regions define x28. So this is how we define a variable. X is 28. So let's just play with that. So I'm assuming maybe I do this. Let's define x as the number 28, and let's see what happens if I try to print x. Does that do what I think it's going to do? Should it print 20x? 28? It's being a little slow. I'll give it some time. Procedure calls. Okay, yep, this I'm familiar with from Clojure, aka Lisp. I mean, Clojure is its own language, but it's based on Lisp. Okay. So basically, what this is saying is that if language expressions. Okay. Define reverse subtract as. Okay. So this still hasn't run yet. Fun. If yes, no. 3, and that's the other thing that's always weird about these languages. You always put the operator at the beginning. So in this case, if I wanted to add two numbers, so if I wanted to say like define y, and then I would be like define y as 2 plus 2. Okay, and what this does is to say 2 plus 2, 2 plus 2 is 4. So it executes this parentheses first, and then it's going to execute this parentheses. The way you got to think about it is you have to start with the most innermost parentheses of the expression. So luckily I've done Clojure, so luckily this is not completely unfamiliar, but it's completely painful. Okay, so if I were looking at this expression right here, it says condition. Okay, but first we have to resolve this. So the condition is 3 greater than 2? That's going to be true. So the condition is true. So then if it's true, it will put out greater. If 3 is less than 2, that's true, it'll put out less. Okay, and then since there's no false value because there's nothing after greater, there's no expression after the greater, so this would just basically this would be true. This would return greater. This returns nothing, and I see. So it returns one clause with the second clause. Interesting. Okay. Functional language are definitely a different way of thinking. And this never did load. Triple stopping, please wait. Okay, and then we'll try this again. Print y. Okay, so this time it did print it, but it says unbound symbol y. Y, so let's try it this way. Would it be like this if I want to do that? No. Oh, I see. This is why I didn't spell define y. This should be probably wrapped in parentheses again. Yep, there we go. Okay, so we see here we define x as 28. So then we print x. We define y as 2 plus 2, which is 4. And then we print y. So yeah, these are always tricky languages because, again, it's all in parentheses. But yeah. So let's see here. Let's try something else. So we know how to define a variable and we know how to print the variable. Let's try creating a function. Okay, so a lambda, let's see here. So a function we just use define as well. So let's try that. So let's try the define. Let me see what the syntax they used is. Define, add for, y. Let's just try this. So let's do this. Let's say define add 1. And then that would be x plus 1. Okay. Let me see here. Define reverse subtract x, y. Oh, I see what they did. Okay, they define it as a lambda. Okay. I gotcha. Okay, so what I want to do then is say that add 1 equals a lambda, which is a inline function. And got it. Okay, so it takes an x and returns x plus 1. Okay, yeah. See, that looks kind of weird, doesn't it? So basically, I'm defining a thing. I'm defining a variable called add1, which holds a lambda function. Okay, and the lambda function takes in an argument of x, and then with that x, we run the expression x plus 1. So then the next line, we can do print add 1, 5. So it should print 6 if this worked. Error, unbound symbol x. Let me see here that I x, y, lambda, x, y, x, y. Set error execute, unbound symbol x. Did I spell I did spell lambda wrong, that's why. There we go. Error 5 is not a function. Okay. Why does 5 have to be a function? Add 1. Let me see how they used it. Add. First subtract. 6, 7. Oh, I see. I don't have to put it in parentheses. We just. Because essentially print, and then what I'm printing is this. So I'm passing this as an argument to this. So this is kind of like Ruby-ish, where this gets passed as an argument to this, and this gets passed as an argument to this. So in a sense, we're passing these as arguments to this. This is really the operator, the function. Okay, so in that case, I should do it. Constant one argument. Nope, still doesn't like it. I should probably define a variable is probably what it wants me to do. Define z as add1 5. That's probably what it wants me to do, and then we can print z. So essentially what we're doing is we're defining a new variable called z, which is the result of add1 5. Let's see if that works, and that worked. Okay, good. So we define a function using a lambda. So we're saying that this variable add1 equals this function, and then we run the function and pass that as the definition of this variable z, print z. Okay. And the thing about functional languages is there's no classes or object-oriented programming. There isn't even mutable variables, like in the sense that I can never change the value of z. Okay, all I can do is create new variables or whatnot. So that's the deal. Okay, an if expression. So we see that. Let's try that out. Okay, so we'll say if z, so if z is greater than 5, then yes, no, let's try this. I'm assuming you have to pass in two, I can pass in two separate expressions, so I imagine that then I could do so then let's see here. If it's true, then I want to print greater. And then if it's false, I want to print lesser. Okay. And the way I would understand this, like if is technically a function that takes in 3 arguments. So the first argument is the expression. So this really is going to return true. And then if this is true, then I'll run the second argument. If it's false, it'll run the third argument. So let's see if my understanding of this is correct. Error 6 is not a function. Where did I use 6? Define z, add 1. Oh, I see, because I put parentheses. Whenever I put a parentheses, the first thing's got to be a function. So let's try if I do that. So it's returning a function. If z is greater than 5. And if I do this, let's see here. Okay, if, where's that if statement? So if this expression, what I see is like, oh, that's right, because the operator has to go first. Oops. That's right. Because technically the operator is a function. Because it's functional programming. And that's how it works. So z is greater than 5. So it's complaining that z is not a function, but the greater than symbol is a function. And that works. Okay, and let's try to make it less than 5. So if I change this to 3, lesser. Okay, good. Okay, so if this is true, it runs this next expression, and if not, it runs the second expression after that. Cool, so that works for me. So we've defined functions, we've done, let me see if there's loops, binding constructs, here we go, iteration. Oy, the syntax on functional languages is so sort of different. Variable bindings body, so some implementations came from a variant of the syntax that's called, let's see here, syntax bindings do. Binding should have the form of variable init step 1. So do I don't really write that the most clear in the world. Okay, variable 1 init 1 step 1. The test expression. So we'll see here. If I go to do, this is the first expression, so that would be the bindings. Then the second expression starts with this parentheses, ends with that parentheses. So sum 0. And then the third expression is the body. It's null sum, which ends here. Not very clear. I'd have to play around with this a little bit more. I can probably find a better explanation of loops and scheme. Loops in scheme. No. Here we go. So let's see. Your scheme is very odd in one sense. It has no expressions designed for looping, repeating, or otherwise doing something more than once at a general level. The easy way to do this is recursion. That is, we're designing a procedure that runs and meets two criteria. So recursion is one way of looping. So I could do something like this. So I could, let me try to define a recursive function. Define loop that is a lambda that takes in an argument of x, and then in the body of the function, if the if is greater than, so if x is greater than 0, then what it's going to do is print x and then loop x minus 1. Okay, and then if that doesn't happen, then what it'll do is that it will return I don't think you use a return keyword here, so it'll just return 0 plus 0. Or let's just say print 0. Okay. So the first time, let's say I make it 5. 5 is greater than 0. So it's going to print 5, then run the function again with 4 until it gets down to 0, and then it's just going to print 0 and stop. At least that's the way I think I understand it. So again, define loop, lambda, blah, blah, blah. So let's actually run the function. Loop. And as you can see, like, this isn't the easiest code or syntax to read. Yay for sort of list-based languages. There's some people who like swear by this stuff. Let's see here, loop. And we're going to loop 5. And let's just see if that works the way we think it was going to work. Unbound x minus 1. Oh, that's right. That takes a while to get used to. Okay. Okay, lesser 0, 1. There's not a function error. Undefined is not a function. Loop, 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 loop. Print. Okay, let's see here about returning a value. Define a lambda. Conditionals, lambda expressions. 4. 710. Back to the REPL. Let's read this error. Undefined. It's not a function. Loop, 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 loop. Print. See here, x. X. If, and there, print x. Greater than 0. Print x. If not, use loop, but apparently loop is not a function, but it should be because it's using it, but I guess because it's a lambda. Is there another way to define functions in Scheme? Define. Here we go. Simple recursion. Define lambda n if. Actually, now that makes me think. No. Let's do it that way. If x equals 0. No, I don't know. I want to do it if it's greater. If it's greater than 0, then do that. If else. Let's see here. Times n. So what we're saying here is that if n is equal to 0, then return 1 or else. Okay, so let's just guess do that. Let's just return 0 here. Define. We are using n times n times the result of, so I'm assuming this is a factorial, minus n1. That's essentially what I'm doing. So let me read this again. Define loop. Oh wait, that's way too many parentheses there. Oh no, this is parentheses here. C is there. Lambda takes an argument x, so loop. And if for x is greater than 0, then we're going to print x. And if not, we will return 0. It's not a function. Loop, 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 loop. Let me copy the example. Let's see if this example works. So I'm going to comment this out. And then we'll just do this. 120. So that works. Okay, and that's a recursive function. I mean, I see it. Just trying to, I still don't see why mine did not. Okay, why is that still green? Let's break this down a little bit. Define loop. Okay. Okay. So if we'll just let's see how they did that. Guess I can only do this. with this, we'll just make x. So that we just return x at the end. Okay, we'll just comment that. And then we'll try this again, loop 5. Because again, what we're doing here is if we define the loop, it's a lambda that takes x as an argument. If x is greater than 0, which 5 is, then it'll run the loop function again. Although that seems like 1, 2, 3, 1, 2, 3 parentheses. Yep, that makes sense. Although, why do I have this one? I don't think I need this one here. Okay, and then otherwise it'll do x. Okay, so that time it worked. Okay. That works. Just because it returns 0, which would be what it returns, x would be on the very last loop. Okay. But yeah, so that's Scheme in a nutshell. Other languages like Lisp, Clojure are going to have very similar syntax. So, you know, if you kind of start following this, you kind of would be able to also learn those languages. There aren't that many languages that have this kind of functional language syntax. This is where functional languages become harder to learn, because a lot of the general purpose languages like Python, C++, Ruby, JavaScript, Java, they kind of have a much more similar syntax between them. While functional programming like this is a little bit different. But I will see you guys later. My name is Alex Merced from alexmercedcoder.com.